Welcome back to Patch Math, where today we are going to finish off our exponent rules by moving on down to zeroth exponent rule and negative exponent rule. You'll see here we are almost done with our list. I'll be saving fractional exponent rule for another day. So for the meantime, we are done for our list. This video finishes this list down to negative exponent rule. All right, so zero exponent rule. It simply says anything in existence. Actually, scratch that. There's one example that doesn't work, but anything, almost anything in existence raised to the 0th power is 1. So when I say that, I mean x. Mouse is messing up. My apologies. I mean x to the 0th power is 1. I mean, as long as x, y, and z are in parentheses, all of that raised to the 0th power is 1. If we have 246 times x times y to the 1000th power, or as long as every single bit of that is in parentheses and raised to the 0th power, it will simplify down to 1. All right. Now, that being said, a few examples you might see that vary just a little bit. Here is an example where we have a number 7 raised to the 0th power. Guess what? That's also a 1. Now, on this next one, we have to be a little bit careful. It is only what the 0 is directly connected to that will become 1. If there were a parentheses around this, that's a vastly different problem than if there were not a parentheses. So that is important. Let's just say, for example, go ahead and do the one with parentheses. Let's say we had 8x in parentheses, all raised to the 0th power. Well, based on everything we've learned so far, we know that will be 1. However, if the parentheses is not there, then that 0th power is only directly connected to that x. Only x is being affected by the 0th power, not the 8. So we write the 8 on down. And then guess what? X to the 0th power becomes 1, and this is 8 times 1. And we know that 8 times 1 is just 8, and we are done. All right, end of a long day. I think my mouse is starting to give out. There you have it, 0th power rule. Now, let's look at the negative exponent rule. If you have a base raised to a negative exponent, there's a variety of ways we could define this, but I'm just going to go ahead and define it the way I like to. It says, hey, I'm in the wrong part of the fraction. If I'm in the numerator and I have a negative exponent, move me and my base to the denominator and make my exponent positive. If your base with your negative exponent is already in your denominator, it's still screaming, hey, this negative exponent says I'm in the wrong part of the fraction. Move me from the denominator to the numerator, make that exponent positive, and you are done. So looking here at these two examples, you'll see we have 11 raised to a negative 4. Our base is 11. Our exponent is negative 4. If this is not already a fraction, you're going to want to make it a fraction. Recognize we have invisible ones in a lot of places in mathematics, and we can make any number a fraction by sticking it over 1. Well, this simply says, hey, I'm in the wrong part of the fraction. Moving to the other part of the fraction and make my exponent positive. Now, because we moved that down, there becomes an invisible one in our numerator as well. And we're done. Looking at number 2, it's already a fraction, and its exponent says, hey, I'm in the wrong part of the fraction. Move me to the other part of the fraction and make my exponent positive. And we are done. Now, I did notice I did not go ahead and simplify these out. Some of your teachers would probably want you to do that. Let me go ahead and do that. 11 to the fourth power is 14,641. All right. And 6 to the fourth power. Well, that is 1,296. And because that is over 1, we can go ahead and drop that 1. In other words, this was just 6 to the fourth power. And if you'll see, this next example is going to be how you'll see both negative exponent and zero rule probably occur at the same time. So we're going to want to simplify the inside first, if at all possible. And you'll see here we do have a q to the 0 power. Please be careful. That 0 in this case is only attached to that q. Only the q to the 0 power becomes 1. So this is 3p times 1. And we know that 3p times 1 is just 3p. So this is just 3p raised to the negative 2 power. Now, if we wanted to, we could go ahead and bring that negative 2 power in using the power of a product rule. And you very well can. However, I want to go ahead and correct the negative on that negative 2 by making this a fraction. And recognize there is an invisible one hanging out up front. We got a bunch of invisible ones here, and they come in handy when correcting our negative exponents. Looking here, everything in parentheses is raised to that negative exponent. That negative exponent says, hey, I'm in the wrong part of the fraction. Move my entire base to the other part of the fraction and make my exponent positive, and you are done. Now that's where the invisible one, the numerator, becomes important, because when we move that numerator down, we need something as a placeholder there, and it's 1. All right, now the placeholder we have in the denominator, it goes away because 1 times 3 p all squared is 3p all squared. Now we can apply our power of a product rule that says if we have a product raised to a power, we can bring each part of that product, aka our factors, and raise them each to that exponent. And 3 squared is 9, and p squared is just p squared. So this is 1 over 9 p squared, and we are done. And there you have it, negative exponent rule and zero exponent rule taught together. Thank you so much for your time.